Hello everyone and welcome back again to object recognition using AI and deep learning. So for object detection we'll be using OpenCV and Python and Raspberry Pi 4. So using these tools we will be trying to detect and recognize an object. So but in this particular session we will be recognizing faces, human faces. So let's get started. Going to programming, Genie. So here we have to create and define and write three programs, Python programs for face recognition. First, what we'll do is we will be creating a data set. We will be creating a data set of an input image, the face to be recognized. So as we execute this program, then when the camera faces the person's face, then it takes 30 photos and clicks 30 images, so that it stores in a folder called dataset. I'll show that. So here it is. This is a fake recognition folder. In this folder we have dataset folder and trainer. And so in the current working directory we have to create these two folders. And in these two folders, whenever we execute the face dataset.py program, then this program, what does it do is it takes the ID from the user, accepts the ID number from the user, and it stores and clicks 30 images of the person to be recognized. And then if we move further, when we execute face training.py, what does it do? It trains the faces and creates trainer.yml program. I'll show that too. This is the file trainer.yml. In this file we have a lot number of faces and trained faces. We will be understanding each and everything here. And then finally, when we execute face recognition.py program, it opens up the camera live video, and then whenever that comes in front of the camera, it recognizes it and displays with the ID number. So let's get started with the first program. Okay, so dataset for storing face features code. Here we need to import OpenCV package, so import CV2 and then import OS. Here we are importing OS because we need to define some OS operating system related functionality. So we are importing OS here, and then what we are going to do is we are going to video capture a live video from the camera of the Raspberry Pi. So this is cv2.video capture function 0, because we are connecting only one camera, and then we are taking that storing that in variable cam. And here we are setting video width and height using cam.set function 3,640 4,480. This is what the dimensions we want to define. And after this we will be using function cascade classifier with har cascade frontal face default.xml file. So as we have already discussed in object detection, this function is used to train the features stored in this XML file. So this XML file has got the facial features. So already trained set of features and already stored set of features. So it has extracted in this file, it has extracted some features from face specific features like eyes, nose and eyebrows. All those features are already stored in this file. So cascade classifier has got an algorithm which applies to these features, and those features now and stored in face detector. So this is inbuilt function defined in OpenCV CV2 package. And after this, we will be, if we move further, we will be accepting first, before moving further, we will be accepting the ID number from the user, so that we will assign that ID number to the face. Okay, so we are storing that in face ID. Input is a function where we will be asking user to give the input, and then this is print initializing face capture, face the camera, and wait. We have to look at the camera and then wait so that it takes some photos until unless it prompts that it is finished. And then we are initializing count to 0 so that it takes 30 photos. This is what the variable we are using for taking a number of photos. And then we are going to enter while loop, and if we are when we are declaring true expression, then it's going to execute indefinitely until unless we break with this special condition. And then here we are capturing the image from the live video cam.read function, and that is stored in variable img and ret. So as we know that we will be using a function detect multi-scale, this function always uses gray color space of the input image. So we have to convert this image into grayscale. For that we will be using cv2.cvt color function. It takes input img as an input image variable, and then it has the flag argument input cv2.color bgr to gray. This is what the code used to convert bgr, or you can say rgb, to gray space. Alright, and that is stored in gray variable. And then what we are doing is we are using here executing detect multi-scale function, which extracts objects, required objects from the image, gray image. And this is what the size of the scale factor to be reduced. Okay, and this is thickness. Okay, so detect multi-scale extracts features from detect multi-scale gets the object detected using cascade classifier. So we are interested only in faces. Throughout the image it searches for the faces. So when it has got the faces, so it stores those faces, those objects, in faces variable. Again here we are using for loop to define to outline and draw rectangle so that it will be highlighted in the image. So for that we'll be using cv2.rectangle function. Rectangle function uses img as input image, which is the input image and variable, and then these are the dimensions and location. And then this is a color bgr, it takes in reverse manner. So instead of rgb, Python takes it as a reverse manner. So blue is a color which will be using to draw rectangle, and 2 is the thickness. Okay, and then it counts this count variable is increment to 1 in each iteration in the for loop. Now we are going to save the captured image in datasets folder. Okay, we have got that captured image, the object we have taken, and that image has to be saved in dataset folder. So what we are going to do is to save, we are using cv2.imwrite. imwrite is the image function used to save in a particular folder. So this is the path we have to define. Dataset is the folder we have already created in our current working directory. And then what we are going to do is we are going to give some identification like 1.2, 1.3 to up to 1.30, 30 images dot jpg. So this is what the function is doing. User dot plus means we are just appending that this face id, we are converting it to string function and string format, and then we are appending that to this path. and then same we are doing, we are appending dot, and then again we are appending count, the value of count variable. It start from 0 up to 29, and then we are again appending here the extension of the file, and this indicates that we are using the gray form of this image, and that will be showing using IMShow function. So image is the title name of the window to be displayed, and then img is the input image what we have received during and what we have captured during live feed. Okay, so and then it will be counted until and unless we reach the count to 30, or else if you want to skip, and we can press escape also, but that is not recommended. So we have to wait as till we get the 30 images. More and more images, more accurate will be the operation. Okay, after this dataset file, we will move on to face training.py. So this file simply trains the in captured images, captured input faces, so that it is trained in a particular manner. So what is the meaning of training here? We are using function lbph. This is actually linear binary patterns histogram. This is an algorithm which is used to train the algorithm with the input set of faces. Okay, so this algorithm performs some internal operations that is helpful in creating a vector pattern, and which is recognizable by the computer. So there are three methods usually followed: Fisher faces, Agent faces, and finally LBPH, linear binary patterns histogram. This linear binary pattern algorithm is proved to be more accurate than rest of the two methods. So it actually focuses on creating vector patterns of the features of an object. So we will be using this, and this is defined inbuilt in OpenCV function, OpenCV package. So let's go ahead. So we are again here importing. We have to import OpenCV package CV2, and here we are importing NumPy numerical package and denoting it as NP. And then from PIL import, we are importing image package, and here we are importing OS because we need to perform some OS related functionality. And then here first statement we are defining the path of the dataset, so that we will be using in our upcoming functions statements. So this is what the path I have used, which is what is stored here. And then I'm using os.chdr. This changes the current working directory to a different path. So har cascades, we want to include this in data, so we are using this function, and then we are using create lbph face recognizer function. So as I have told you, this function performs linear binary pattern algorithm and trains the input images using this particular pattern algorithm, so that it in output side it creates some vectors which are used to differentiate and compare with each and every other image for the purpose of recognition. So its output will be used for face recognition program. So it creates vector patterns which will be helpful in recognition. Alright, so as a result of this execution of face training.py, we will get trainer.yml file in which which will be read by face recognition program, and then that which will act as an input to face recognition, and then it will be performing comparison functions. Alright, so we'll be using this, and you see it is defined in CV2, and we have one more file here, phase. In that it is defined create lbph phase recognizer function, and that we are storing it in recognizer variable, our own defined variable. After that we'll be defining this function and as we have already discussed, we'll be assigning this hard cascade frontal phase default xml file along with the path to cascade classify function. Okay, and then we are storing that in detector. Okay, so again we have to perform this to get detected. So once detection is over, we'll be training that, and then we'll be performing recognition operation. Okay, now here we will be defining one function, get images and variable. We get images and labels. So in this function we'll be taking images which we have stored in dataset, and then we'll be assigning those images with some labels. So this takes path, the directory path, the location path as an input argument. So first we'll be defining image paths variable, where we will be assigning the path of each image. So you can see this os.path.join, which takes this join function, which takes path comma f as its input arguments. Path we have already defined here. This is what the path of the data set. Okay, and then after this we'll be executing for loop, in which we will be using the directory path and assigning it to join function. So after this we have to define phase samples and IDs as two variables, array variables, so which will be using it in our further upcoming functions to assign IDs to each image. And this is the phase samples. We'll be storing the phase samples. Okay, now again we are defining for loop, in which we'll be again taking the image paths. All right, so for detect multi-scale function we have to use grayscale format. So we'll be converting this image into grayscale. All right, and that we are storing in pil image img variable, and then here we are creating one array, np.array, and it takes input image as an argument, and this is what the format it's going to return. So it returns array in the form of uint8 size, 8 bits size, and that will be storing in img numpy variable. All right, so after this we are taking id and we are converting this expression to int format, integer format, and we are passing this as an so let's go through this. os.path.split. Split is a function. We are splitting image path with the extension. Okay, so split is the function used for this, and then after this we are using faces variable, and detector dot detect multi-scale, this we have already discussed. It is going to extract those objects, and we are storing those, that here objects are faces, and we are storing faces variable. After this we will be executing for loop, so that we append those face samples with this image numpy variable, because we have created one array here. All right, so face samples dot append is the function here, and then ids dot append, input argument as id. Now here in this for loop we are appending IDs and image labels to each faces images. Okay, and then it returns its face samples and IDs. Okay, so here we are able to, in this function we are able to append or we can say assign IDs or identification numbers to each sample image, and then we are storing those face samples in face samples variables, and training phases will, and this is the print function will be in outputting it to the user, so that the user waits patiently. After this we will be executing this get images and labels function, and those values returned will be stored in faces and IDs variables. And now we are using recognizer dot train function. So what is recognizer? Here we have defined this cv2 dot face dot create lbph face recognizer function, so that we are here executing, and dot train is defined in recognizer variable now, and this train function is trains algorithm that it has so and so features. Each phase has so and so vectors that will be performed using train function, and it takes faces as the input variable, and np.array of IDs is what we had to define here, which creates arrays of ID. So ID is created in transformed in the form of array using np.array function. Now after this train function is gets executed, we will be we get the array in as a result of this function, and those arrays will be stored in one file called trainer.yml, and that we are defining in recognizer save in this path location we are defining here, and recognizer.save function is used to save and that file. So this trainer.yml will be called by a face recognition program to recognize and compare the output image, the input image we get from the live video, so that it searches that face image from the stored images, and those stored images are in dataset, but we have transformed that into vector patterns using face training.py, that it is stored, those data is stored in trainer.yml file. Okay, once it is finished we'll be outputting faces train exiting program. Alright, so now let's go to face recognition program. In this we will be simply comparing the input image we get, and we'll compare that input image with the images we have got in our store, what we have stored and saved in our folder dataset and trainer.yml, and we will comparing it. If there is a match with the features with the vector patterns, then we'll be assigning that and showing that this is so and so Mr. X, Mr. Y. We'll be giving some names here already we have to define here, and then that will be displaying on the window. Okay, let's see how we can do that. So we are importing OpenCV package, and then numerical Python, and then OS function, OS package. Now we have to change the directory first here, current working directory to a different path, hard cascades. Okay, now again here we'll be defining create lbph face recognizer function, and that is defined in face, and which is defined in cv2 package, and that we are storing it in recognizer right now. Now first of all we'll be loading, we have to read, or we can say load the file trainer.yml as we have discussed in just now. that the trainer.yml will be used to take we used to compare our input image with the stored images. Those stored images are stored in a trainer.yml file. Now here again we have to use cascade path. This path of har cascade frontal face default.xml file, we are right now storing it in cascade path, because we are going to call cascade classifier function. We could have directly written this, but this time we are using cascade path variable so that it is easy to read and understand. And that we are storing the result of this cascade classifier, we are storing in face cascade, because these cascade classifier function outputs objects like faces and that we are storing in face cascade. Now this is a font Hershey simplex, which is defined in CV2. This type of font we want to we want to display it, the name, the ID in the form, in which form we have to display. We are using that format here. We can define a number of fonts here, but right now we are choosing font Hershey simplex. Okay, so we we are defining one variable ID is equal to 0, initializing it, and then we are defining string variable names so that we can assign a particular name to the recognized object, that is face. This is 0th location, first location, second and third. If we are when we are say ID is 1 while training, while giving input, if we say ID is 1, so this name will be displayed, Mr. X. If we say ID 2, then Mr. Y will be displayed along with the captured face, if it is or recognized face. Okay, all right. And then we are capturing the video capture, and we are taking a live feed and storing in cam. We are defining here the dimensions of the video using cam.set function. After this, min w and min h, these are width and height of the recognized face. So we are defining the minimum limit of the face, after which we will be going ahead to recognize it. We won't recognize faces beyond this, so we have to define limit here. If the faces are smaller, if the face object are smaller than this window size, then we won't count it, and we will just ignore it, and we won't even detect that. So we are defining this. You can change this, and that we are using cam.get function. Okay, and then we are entering while loop. True means we are going to execute it indefinitely, and later we will define one function to break this. And cam.read function is the function which is used to capture images and read into img and ret variables. Here cvt color is the function which we are using to convert RGB to grayscale images. Okay, and then faces is equal to face cascade dot detect multi-scale. This is going to extract those objects, only objects and faces, and will be storing it in faces. As we have seen earlier, it takes grayscale of form of image as an input argument, and scale factor is 1.2, which we want to resize it to a particular size, and then minimum neighbors 5. What the minimum neighbors is, because this LBP, linear binary pattern, this algorithm uses one technique. It takes and it concentrates on particular set of pixels, and it defines one centralized pixel, and that centralized pixel is compared, or you can say thresholded with the neighboring pixels. So this is what the limit we want to define, number of neighbors we want to compare it with, and it gives a binary output of that image. And then min size is the minimum size. We want to concentrate on the number of pixels, set of pixels. And then here we are entering a for loop. In this for loop we will be defining outline and drawing rectangles around the faces, detected faces, and on that faces we want to put the ID and name. We won't be displaying ID in this program, but we will be displaying name of that person which we have defined in names string length, string set of string, and we will be displaying the confidence. This is recognizer.predict function is used to predict that this so and so detected face belong to our stored set of faces. So that confidence level we want to define. So the confidence level is actually the accuracy the our algorithm want to output. So we will be considering one confidence level. If it surpasses like 50% or so, then we say that it is accurate. Otherwise we will just ignoring it and say it's unknown. But those confidence level is defined here. Okay, this is we are converting to percentage here, and then we want to put this text and display it on the display image window. We are outputting the ID but with the name. This time the names we are outputting, and then we will be displaying the confidence in percentage. Okay, the font we have already defined font here. These are the colors we want to define. Okay, and this is thickness. Alright, c2.I'm show is the image show function which is used to display the resulting image, and camera is what we want to display as a title name, and it will be continue until and unless we press escape key, after which the while loop will be broken and will come out of the while loop and will exit program. After this we will be releasing the camera using cam.release function, after which we'll be destroying all windows to exit the program. Okay, let's go to face dataset and execute the program. Okay, go to build and say execute. So I'll be using my mobile phone to train the face. Okay, for this I'll be defining ID number 1 so that it goes ahead and assign that ID to this. Okay, this is what we were able to train the image. I have got this random image from my internet, so that I can train different faces live. Even you can train your own face also, no problem. Okay, then for this to be stored, we will be executing this face training.py. Okay, it's executing. Okay, it's only a few seconds task. That input faces what we have got in dataset folder, it will be trained and transformed into vector patterns and stored in trainer.yml file, as we have already discussed here. Okay, what we have trained here is dataset, which I will show this. This is what the number of images it has stored in when we say id 1. Let's see, open this. So you can see this, it has taken a grayscale form. Look, it has taken 30 photos of this images. Alright, and let's be accurate. Okay, enter id 1. Just show the face. Train it using face training.py. It will train automatically and execute those function lbph. Okay, done. Go to face recognition and execute again. Let's see, will it recognize it as Mr. X? Yes, clearly it is recognizing it as Mr. X. We are not bothered about the other images because it is smaller in size. Okay, now it is okay. So it is Mr. X, and the confidence level, percentage is not crossing 25 even. So no problem. Okay, let's train one more image. Go to dataset, say execute. See, now next image will be training. Okay, it's going to take 30 images. I think it has taken those images. Now train that. Okay, done that successfully, and go to face recognition, execute it. Now it should say Mr. Y. It is clearly indicating that it is Mr. Y. Okay, alright. So this is how you train the faces and recognize. Let's go to dataset. If you want, you can train one more face here. Say 3. Face the camera and wait. Okay, one more face we have captured, and let's train that face. Okay, done it. Go to face recognition and just open it. Now I should say something. Mr. Z. Okay, now it's alright. Mr. Z, because we have trained that, and even we will check this previously trained faces, Mr. Y. Even this is also detecting. And this is Mr. X, which we have already trained. So we have trained 3 faces here. So we can train any number of faces. It depends on the memory. exit the program. So this is all about face recognition. Just go ahead and try this, and just make sure dataset and trainer folders are in the same working directory. Otherwise you have to give the path of it. Then you can go ahead and try yourself. Hope you understand this, and see you in next tutorials.